Welcome to the first in a series of quick videos where I'll talk you through the making of Lotus STE. The sharp-eyed amongst you may notice that the cars and scenery jerk sideways across the screen in the standard ST version of Lotus. This is in contrast to the Amiga version where they appear to move smoothly across the screen. One of the things we wanted to do with Lotus STE is update it so that the cars and scenery would move smoothly sideways across the screen as they do in the Amiga version. The reason for the jerky sideways movement is down to the way video memory is organised on the ST using a technique called bit planes. This means that it's very fast to draw the cars and scenery at intervals of 16 pixels, but very time consuming to do this at any other positions. If we want to draw our sprites at arbitrary horizontal positions, the CPU is faced with a series of quite complex calculations in order to do so, affecting the frame rate of our game. A good example of a game that does this is Turbo Cup. It's a great looking game, but the frame rate is far from ideal. This performance issue can be worked around using a technique called pre-shifting, which performs the complex calculations before the game is run and stores the cars and scenery multiple times in memory at different positions. For example, we could store a second copy of the sprite shifted 8 pixels to the right, and this would allow us to draw sprites quickly at 8 pixel intervals, rather than 16 pixel intervals. This looks better, but we've suddenly doubled the memory requirement to our sprites. If we wanted to take the use of pre-shifting to its logical conclusion and render sprites at 1 pixel intervals, we're going to run out of memory very quickly on a 512K ST. The authors of Lotus chose not to make use of pre-shifting, meaning that our cars and scenery are rendered at 16 pixel horizontal intervals. Enter the Blitter chip in the STE. The 68000 CPU in the ST is a general purpose processor, whereas the Blitter is specialised towards certain tasks. It just so happens that one of the capabilities of the Blitter, known as skew, gives it the ability to perform the calculations required to position sprites at arbitrary horizontal positions much more quickly than the CPU. It's so quick at doing this that we can completely forget about the need for pre-shifting. In order to draw cars and scenery on the screen using the Blitter, we first erase the background to black by performing 4 AND passes on the 4-bit planes of the screen using the mask data of the sprite. Following this, we then perform either 3 or 4 OR passes, depending upon the sprite in question, to fill in the detail. So that's 7 or 8 calls to the Blitter in order to draw one sprite on the screen. We also need to make use of an additional feature called end mask to make sure that the left and right edges of our sprite aren't displaying things that don't need to be displayed. Looking at our finished sprite rendering code, there's just one problem. It looks like we have a few graphics and sound glitches. The reason for this is that when the Blitter is working, the CPU is stopped, meaning that other parts of the game that depend upon the CPU, like the music playback and sky gradient, are at risk of getting broken. Unlike in the Amiga, the Blitter doesn't work very well in harmony with the rest of the STE hardware, and we have to come up with workarounds. In this case, we split each call to the Blitter into 1 or more lines at a time. The wider a sprite is, the less lines we aim to draw at a time. This ensures that the CPU gets a sufficient share of time and that other parts of the game therefore don't suffer. There's obviously a speed penalty to doing things this way, but it's a worthy compromise given the alternatives. That's it for now. Thanks for watching. Please like and subscribe so I can continue making these videos.